Hi, and welcome to our last video for Unit 1. Today we're going to be talking about statistics and how they're used in psychology. So if you are a big math person, this is great, but even if you're not, don't worry because we're not going to be doing calculations. We're just going to figure out what the statistics mean, how to determine if something is statistically significant, and all that stuff. So if you're not a fan of math like myself, don't worry. It is okay. You're not going to have to do math calculations. So let's look at our learning targets. We have some things that we're going to look at in this video. Make sure that you always go back and look at your learning targets to see if you learned that information and if you understand it. And then make sure you have your notes. These are the last 2 slides in your digital notebook, and because we're almost done with Unit 1. Okay, statistical reasoning. So we have certain procedures that help us analyze and interpret data to let us see what maybe the unaided eye misses. So if you're looking at something with bias or from your own environment, sometimes you can miss things. So statistics are a really good way to provide data to allow us to analyze and interpret it so we can understand what's going on. So if you look at our statistics down here, we have the population, the median household income, and the poverty rate for the state of Texas. And that just kind of gives you, oh, there's the bell. It just gives you some important information about where you live. Now, sometimes when you have to describe the data, there's certain ways that we can do that to where we make sure that the data is meaningful, because sometimes if you misrepresent it, it can come to incorrect conclusions. So if you look down at the 2 graphs, you can see that they're measuring the same thing. You have your brand of truck. You have our brand, so the brand that's putting out this data. Then you have brand X, Y, and Z. And you have the percentage of the trucks that are still functioning after 10 years. Well, if you look at the graph on the left, it looks like all of the brands are pretty equal. You have brand Z that's a little bit lower than the other brands, but it looks like they're all pretty equivalent. However, if you look at another graph measuring the same thing, it looks like brand Z is not doing very well, and the brand that's advertising this is doing really well. Well, what's different? Well, if you look at the y-axis here, you have a different scale. So on the left, it's moving up by 10. And then on the right, it's moving up by 0.5. So it kind of gives us a completely different picture. So if I was to produce the graph on the left, that would give us incorrect information because it would look like we could really go with any of the brands. But if I was to show you the graph on the right, you would know the clear answer, or the correct answer would be to go with the first brand, if you want to buy a truck that's going to function after 10 years. So we want to be really careful on how we describe our data because we don't want to misinform. Okay, so we're going to look at 2 different measures. The first one is the measures of central tendency. So this is going to be your mean, median, and your mode. So hopefully we've heard those before. It's probably taking you back to elementary school a little bit, or at least middle school. But the mean is just the average of scores that you calculated from a distribution by adding all the scores together and dividing by however many there are. The median is just the middle score once you put things in numerical order, and then mode is the score that's going to show up the most frequent. Not going to spend a lot of time on that because you should know it. If you ever have to do any calculations in psychology, they might just tell you to calculate the mean or the mode or the median. So that's about as much math as we're going to do here. So for my friends who hate math, hopefully that's a comfort for you. We also have our measures of variation. So we're going to look at 2 different things here. We're going to look at the range, which should also probably be pretty familiar to you. That's just the difference between the highest score and the lowest scores in the distribution. We're just trying to find the difference. With standard deviation, this term might be new to you unless you have taken some sort of statistics course like AP Stat. But this is the average distance between a score and the mean. So I like to think of it as how far away is that score from the mean. So we might say that it's 2 standard deviations above the mean or 1 standard deviation below the mean, showing you in relation to the mean where that score is. It can either be above or below. Okay, so you usually don't ever have to calculate standard deviation like you would in AP statistics with that long formula. Sometimes they might tell you the variance, and you can find the standard deviation very easily from that. So a really good way to find the standard deviation is just to take the square root of the variance. So the variance, if it's 100, you take the square root, the standard deviation is going to be tens. That's, again, pretty much the most calculation that you're going to have to do. So don't stress about math calculations here. We're just taking that information and applying it. So how do we figure out standard deviation, or at least how do we figure out which set of numbers is going to have the biggest standard deviation without calculating? So we've got 3 different sets of numbers here. The first one is 1, 5, 7, 30. The second one is 5, 10, 12, 18. And the last one is 30, 32, 34, 35. So which one looks like it's spread out the most? Well, if you looked at it, you would think that that would be number 1, right? Because you've got 4 data points and they range anywhere from 1 to 30. That's a pretty big gap. And if you look at the second one, it's a data set that runs from 5 to 18, which is still a decent gap, but it's not as much as 1 to 30. And then the last one, all the data points are very close together, so you're not going to have a very high standard deviation. They're all going to be pretty close to the mean. So you'll see that your greatest standard deviation is going to be this first set right here, because you're going to have data points close to the mean, but also not close to the mean. And standard deviation, remember, tells us how far away you are from the mean. Oops. So how can you figure this out? You can estimate the standard deviation by looking at the spread of numbers. So like I said, this first set has a wide spread, 1 to 30. You can also find the mean of each and then compare each number to the mean. So if we were to find the mean of the last one, it would be in the 30s, and you would see that all the data points are very close to the mean, so we're not going to have a large spread. So that means they're going to be probably within 1 standard deviation above and below the mean, as opposed to the very first set, you might have some that are above and below the mean 2 standard deviations away. Okay, so we're going to look at a normal distribution. So if we have a distribution of scores that creates this bell curve, then we know that it's a normal curve and it's a normal distribution. So in this class, almost 98% of the time, we're going to be dealing with normal distributions. Or it could be called a normal curve, and it just means that the mean, median, and mode are going to fall at exactly the same point. And what's cool about that is it gives you certain percentages that you can always keep in the back of your mind. So if you have to figure out like percentile or something like that, these can help you. So let's look at the normal curve right here. This is for an intelligence test, and it looks like the mean is going to be 100, and you have standard deviations above and below the mean. So our first standard deviation above is going to be this 115, and our first standard deviation below is going to be 85. Well, how far away is 115 from 100? There's a difference of 15, right? Same with 100 to 85. There's a difference of 15. If you keep going, if you add 15 to 115, then you get 130. If you take away 15 from 85, you get 70. So this is telling you that the mean is 100 and the standard deviation is going to be 15. Now, we have certain percentages that tell you how much of the data falls between the different standard deviations. So you'll see that 34% of all of our data is going to fall within one standard deviation above the mean. Now, what's really cool about a normal curve is it's symmetrical. So everything that happens above the mean is going to happen below the mean as well. So it's also saying that 34% of the data falls below one standard deviation from the mean. So together, this is where you get your 68% because you're adding 34 and 34. 68% of the data or of the scores of this intelligence test are going to fall within one standard deviation above and below the mean. I know this is super, super riveting stuff, but these percentages are something that you do need to memorize. Now, not everything is within one standard deviation above and below the mean. Some points fall past that. So if you go up 2 standard deviations, now we have a different percentage. So if we look at just 115 to 130, 14% of the data is going to fall between these 2 standard deviations of 115 and 130. Remember, it's symmetrical, so it's the same thing. So 14% of the data is going to fall within 85 and 70, these 2 standard deviations. Now, if you want to figure out the percentage of data that's going to fall within 2 standard deviations above and below the mean, all you have to do is add these numbers together, which give you a total of 96%. And so that would tell us that 96% fall within 2 standard deviations above and below the mean. So that means their intelligence score fell somewhere in between 70 and 130, which is a majority of the population. However, you do have your extremes, right? So you add your 2% here, 2% here. So if you wanted to figure out the total scores of everyone, that's 3 standard deviations above and below the mean, then you'd add all your percentages up, which here in psychology we round, so that would come out to 98. And then we have some of our friends out here. So if you took AP Stat, these numbers might be slightly different because we're just rounding here because we're not really dealing with calculations. It's just how can we interpret the data. So just be aware of that. Sometimes you might see like 34.1. It's okay. But make sure that you know our basic percentages here of 68% fall within 1 standard deviation above and below the mean. 96% fall within 2 standard deviations above and below the mean. And then we have our 98% is going to fall within 3 standard deviations above and below the mean. So make sure, and that's for every normal curve, which is what we're going to be dealing with mostly here. So make sure that you write those numbers down, you review those numbers, and you memorize those because, like I said, if you're ever dealing with a normal curve, those are the numbers that you're going to look at and you're going to use when you're trying to figure out different percentiles and all of that. Yeah, so you can always remember half the curve. As you can see here, this is a perfect example of how the numbers might be slightly different because we rounded. So sometimes you might see 34.1 or 13.6. It's very similar, okay? Don't let that throw you. So here we're just rounding to make it more even across the board. Sometimes it will be a little bit more precise like that. Okay, so don't let that throw you. Just remember it's pretty close to 34 to 14 into 2. Okay, now sometimes you don't have a normal curve and you have a skewed distribution. So that just means there's some outlier that is skewing the data in either a positive or negative direction. So this is your friend that maybe everyone flunked the test. Like maybe everyone got a 50 or 60, but then one person got 100 and they messed up the whole curve. Don't you just love that person? So that person that got a 100 is the outlier because almost everyone else in the class got a failing grade. So these are just data points that are going to lie at the extreme ends of the curve. That's going to make everything look different. It's going to skew everything. So it's either positive or negative depending on where the outliers are. So if you're looking at this, which measure of central tendency is going to be the most impacted? Do you think it's the mean, the median, or the mode? Well, it's probably going to be the mean, right? Because if you're trying to find the average of something, so if I had 25 kids in the class and 24 of those kids made a 50 on the test, but then you got Joe, number 25, who made a 100, if I average those scores together, I'm going to get a score that's not close to 50, and that is not representative of the class because I got Joe throwing in his 100. But if I was to find the median, if I was to put all those scores in numerical order and find the median, what would the median be? 50. And that's a much better representation of the scores because the median really eliminates the outlier. The outlier isn't as much of a factor as opposed to when you're calculating the mean, because when you're calculating the mean, you have to include that outlier in the finding the average, and that throws everything off. I'll show you an example the next time we meet in class about baseball cards, and I think it might make a little bit more sense to you if you're a little confused here. Okay, inferential statistics. So this is basically us just estimating what is happening in a sample population for the purpose of making decisions about a population's characteristics. So when you hear the word inference, hopefully that means like making an educated guess or estimate or something like that. And that's the same thing that we're going to do here in psychology. We're going to have some statistics and we're going to make inferences about them. That's why they're called inferential statistics. So basically this allows us to say, if something works for this population, we should be able to estimate that it's going to work for the rest of the population. So for example, if you have drug testing, if there were meds that worked for a specific sample, then we can estimate that it's going to have the same effect on the rest of the population as it did on a sample population. Obviously, there's always a chance for error here in whatever our findings might be. So we have to test our hypothesis and our results to make sure they are statistically significant and there's not confounding variables that can allow our results to be not usable. So this is where the null hypothesis comes in. So stick with me here. Honestly, usually there's maybe one question about the null hypothesis. So if this just completely goes over your head and you're still really confused, don't stress about it. Really just kind of focus on the other things in this video, especially like the normal curve and the measures of central tendency. Don't stress about this a ton. And again, if you've taken AP Stats with Mr. Rooks, you're going to be a little ahead of the game. Also, you're going to know that he explains it a lot better than me. So again, don't let this confuse you. We're really just here to talk about it a little bit in case the term null hypothesis does pop up on the test. So you have your hypothesis, which is what you're testing, but then you also have your null hypothesis, which is just saying that there's no difference between two sets of data or two variables. So the purpose is, until the research shows that there's a difference, the researcher must assume that if there is any difference, it's due to chance. So stick with me. I'm going to give you an example that's going to probably make this seem a little bit more clear to you after this. So you have the null hypothesis and you can either accept it or reject it, and then we'll figure out if the null hypothesis was either true or false. Now, sometimes if you accept the original hypothesis and it's wrong, or if you accept the null hypothesis and that was wrong, there can be some errors that pop up. So if you are rejecting the null hypothesis and you're accepting the original hypothesis, that there is a difference between these two sets, that is not due to chance, but you find out that the null hypothesis is true, that's going to come out to a type 1 error. So you're rejecting the null hypothesis even though it's actually true. That's going to come out to a type 1 error. However, sometimes you can accept the null hypothesis that if there is any difference, it's due to chance, but then sometimes that null hypothesis can be false. So that's a type 2 error. You accepted the null hypothesis when the original hypothesis was actually correct. And then, so you can have two types of errors, but then there can also be times when you can get the correct decision of accepting the null hypothesis and it being true. That's a correct decision. Or rejecting the null hypothesis and the null hypothesis was indeed false. So let's give you an example of this instead of just throwing these words at you. So let's take our original hypothesis of that a patient exhibits signs of appendicitis, therefore the appendix needs to be surgically removed. So that's your hypothesis, right? However, we have to include our null hypothesis here because we haven't tested anything. So the null hypothesis is the appendicitis is not the reason for the symptoms, therefore the appendix does not need to be removed. Now let's go through the steps, because if you reject something and it's actually true, you could be putting your patient in a lot of danger, especially with appendicitis. We're not playing with that, right? Okay. So let's say that we reject the null hypothesis and we say, no, I think the patient is exhibiting signs of appendicitis, therefore we need to remove the appendix. However, the null hypothesis is true. Oh shoot. Well, we have an error and we just gave someone surgery that they didn't need and we took out their appendicitis, which they didn't need removed. And so that could be an effect on you as the doctor. You could be sued for malpractice or something like that. However, if we accept the null hypothesis and say, oh yeah, I don't think appendicitis is the reason for the symptoms, we don't need to remove it, and then we figure out that's false, well then you don't remove the appendix, it bursts, the person dies in 24 hours. That's not good, right? So we have to look at both hypotheses and figure out if we're going to reject one and if that's true or false. So now if you rejected the null hypothesis and you said, oh, no, the symptoms are appendicitis, we need to remove the appendix, and then that's correct, you removed it and now they don't have appendicitis, then that's great. The patient is recovering, they're not dying, they don't have their appendix, so it's not going to burst. And then the same thing, if you accept the null hypothesis and say, no, I don't think it's due to appendicitis, and that ends up to be true, then we avoided unnecessary surgery and we're going to look at other causes for the symptoms. So you can pause this, you can rewind it. You can make sure that you kind of understand what happens when we reject or accept either the null hypothesis or the original hypothesis. But again, if you've watched it a couple times and you've paused it a couple times and it's still not making any sense, it's okay. Move on. Study more of the other parts of this video as opposed to this one. Okay, like this page, study this page. So we have to figure out if something is statistically significant. So we want to make sure that our differences between our two groups, our control group and our sample group, are not due to chance. We don't want any differences due to chance. We want the differences to be due to the independent variable. We want to say that this variable causes this to happen, so we want to eliminate as much chance as possible. So data is significant when the likelihood of a difference due to chance is less than 5 times out of 100, or 5%. We want it to be equal to or less than 5%. So if we're looking at this numerically, we're going to use this little lowercase p, and we want it to come out to less or equal than 0.05, which translates into 5%. So then that means we want there to be at least a 95% chance or greater that the difference between the two variables is due to your independent variable. Hopefully that makes sense. It is important that the research is statistically significant because that means the results are not due to chance. It's not a fluke. It's actually significant with the data. So if you come across an experiment and it says the p-value is 6, then that means 60% of it is due to chance, and that's not okay. So you always want this p-value, this lowercase p, to be equal to or less than 0.05 or 5%. We want 95% or greater to be due to the independent variable, not chance. So if you get a p-value that's higher than 5%, then that means we don't have that 95% or greater likelihood that the difference is actually caused by the independent variable. P-value, less than or equal to 0.05 or 5%. It's not higher. We want that number as low as possible. So if you have a p-value of 0.03, that's even better, because then that means 97% of your difference is due to the independent variable. That's good. We want the p-value as low as possible and no higher than 0.05. Okay, that concludes our statistics video. We will be doing some practice with this. We will be doing some review with this. So if this kind of came across as confusing to you, we will talk about it in class 2. I will be there to answer most of your questions. Don't get too deep into statistics because it's just not my expertise. But if you have any questions on how to apply this or anything that came across as confusing, let me know. We'll chat about it. But these are all the videos for Unit 1. We are zooming. So our next unit is going to be about the brain. So some of you might find that a little bit more interesting than this one. But like I said, we'll be using research methods. We'll be using experiments, statistics all year long. And you're probably going to have an FRQ all about it. So make sure that you do understand it and let me know if you have any questions.